how we can test for convergence, and I want to look at three different approaches. And so we can start with our example. We have a series here that we've been given, n from 1 to infinity, summation 3 over 3 raised to power n. And this we can write it as n from 1 to infinity 1 over 3 raised to power n. And so the first method that we would want to attempt to use is we want to use what we call the ratio test. And I want to see how the ratio test works. One of the things we want to keep in mind is that we calculate the value of R, which is given by an plus 1 over an. And if R is less than 1, then the series converges. If R is greater than 1, it diverges. If R is equals to 1, we need to test. So you need to do further testing if the value is equals to 1. Based on that information, we want to single out our an. From the equation, then our an is equals to 1 over 3 n minus 1. And then it automatically means our an plus 1 will be 1 over 3 raised to n. And therefore now we can get the ratio, which is our R, and see how it goes. And we'll know if the series. We are testing for the convergence. So our R will be 1 over 3 raised to power n divided by 1 over 3 raised to power n minus 1, which is 1 over 3 raised to power n times 3 raised to power n minus 1. And that, if we can remember how to go about this, maybe I could explain it further. This will be equals to 1 over 3n times 3 raised to power n divided by 3. And that tells me that my R is that, which is less than 1. So the series converges by the ratio test. So the ratio test helps us to show that the series converges. So that's the first thing that we have seen. Second thing is we want to look at our second equation that we have. And our second equation that we have is given by summation n is equals to 1 to infinity of 2n raised to power 3n. And we want to use another test called the root test. And how does it work? Basically, the idea is the same. R will be equals to the nth root of an, and if R is less than 1, then the test converges. If R is greater than 1, it diverges again, just like in the previous case. And if R is equals to 1, we need to do further testing. But today we are just looking at simple examples on how to test for convergence. So based on that, let's do the tests. So R will be equals to the nth root of 2 over 3 raised to power n, and the nth root, which implies that R is equals to 2 over 3, which is less than 1. So the series converges by the root test. So That's the other thing that we found. So now with the second method, the root test, the series converges. We can look at another method, the third method. And we want to look at an example of an integral. For example, summation from 1 to infinity of n1 squared. And we want to use the integral test. What are we doing? We are testing for the convergence, and therefore what I'll basically do, I'll integrate from 1 to infinity of 1 over x squared dx, and this is the same as negative 1 over x 1 to infinity, which is equals to negative 1 over infinity plus 1, which is 1. And what does that tell us? Because we have got a definite value from our integral, so the series converges by the integral test. So these are some of the examples that we have on how you can use the integral test. There are other ways of looking at it. We can look at even alternating series. We can look at the last example, number 4. And I want to see if it is alternating. How would we approach it? For example, negative 1 raised to power n all over n squared. We have seen 1 over n squared converges. What about this? Remember, this would look something like this. Then plus 1 over 2 squared minus 1 over 3 squared plus 1 over 4 squared, and the list goes on. And this is what we refer to as an alternating series. We refer to this as an alternating series. So we use an alternating series test. And how does the alternating series test work? Alternating series test is also very practical. It converges if the absolute value of an plus 1 all over the absolute value of an is less than or equals to 1. And then definitely if it is greater than 1, then it diverges. So we have to get the absolute value. And so if you get the absolute value, we'll definitely be left with a very simple equation. So my R will be equals, the absolute value will be n plus 1 squared all over n squared. Because the other one is a negative value, and this gives me an equation of the form n squared plus 2n plus 1 all over n squared. So I can get limit as n tends to infinity of 1 plus 2 over n plus 1 over n squared, and this will tend towards 1. So thus converges. So the series converges. That should have been a little bit better, because the value of R. Why have I said that? Because now I see R is equals to 1, and this shows that series converges. Because we have said if it's less than or equals to 1, then it is going to converge using the method. We call it by alternating series test that we have applied. So those are some of the approaches that we could take when we are doing some of these tests for convergence.